Hi everyone. Today we will learn HPA in Kubernetes. So what's HPA? HPA basically its a full form is that horizontal pod autoscaling. So in Kubernetes, horizontal pod autoscaler automatically updates a workload resource such as deployment or any stateful set. So with the aim of automatically scaling the workload to match the demand. So suppose you are running any application on in Kubernetes and it has normal traffic and you have said that always 5 pods should run. But what happens when traffic suddenly increase? There is sudden spike on your traffic. So you have to do some configuration so that it auto scale from 5 pods to 10 pods or 15 pods to handle the traffic. So that is so for this we use the HPA, that is horizontal pod auto scaling. So basically first understand the difference between horizontal pod scaling and vertical scaling. But before going in deep, this is the link of my YouTube channel. Please subscribe and keep updated with the latest and upcoming videos. So what I was saying that we have to first understand the difference between horizontal scaling and vertical scaling. So in horizontal scaling means that the response to increased load is to deploy more pods. So suppose when your traffic increase, you increase the number of pods. So suppose 5 pods are running, you can increase the pod to 7, 8, 10, 15 depend on the traffic for that particular period of time, or depend on the resource utilization of the suppose your CPU reached more than 70%, 50% by the utilization by the pod, then in that case you can increase the number of pods. So that is called the horizontal scaling. So horizontal scaling means the increasing the number of pods to handle the load. But vertical scaling is assigning more resource to the pod. So suppose you have there are 5 existing pods. So in vertical scaling, you have to assign more resource. Suppose you want to give the more memory to the pod, or you want to assign the more CPU to the pod. In that case, you will do the vertical scaling. So vertical scaling is assigning the resource to the pods which are already running. So now in horizontal scaling, so if the load decrease, the number of pods is above the configured minimum, the horizontal pod scaler instruct the workload resource to scale back down to decrease the number of, suppose your normal CPU 30% and 5 pods are running. When load increase due to any reason, due to traffic or some other incident, your CPU utilization increase to 60%, 70%. In that case, your pods number will increase from 5 to 10. And when load back to the normal around 30%, the number of pods will also decrease to the original number, that is the 5 numbers, which are the by default you have set. Here one thing to remember that horizontal pod auto scaling does not apply to the objects that can't be scaled. For example, the daemon set. You cannot implement auto scaling in daemon set. So let's understand with this diagram. So this is here HPA work, horizontal pod scaling. You have the deployment or replica set. When you scale pod 1, pod 2, pod 3, pod 4, pod 5, pod 6, pod n can be running after auto scaling. So basically here HPA, that is horizontal pod autoscaler, control the scale of a deployment, and it's a replica set. So basically it is it auto scales as a control loop that runs intermittently. It is not a continuous process. Means that there is a interval set by the horizontal pod autoscaler sync period, which that is the parameter which continuously check the it needs the HPA, there is a requirement of HPA or not. So by default it is a 15 second. So basically it is set in Cube Controller Manager, and default value is 15 second, which periodically check and implement the HPA logic. So there are few points you need to understand about the HPA. So basically it is used to handle the increased load, deploy more pods. It is totally different from vertical scaling. Vertical scaling is to assign the more resources like memory or CPU to the already running pods. But horizontal scaling is to increase or decrease the number of pods. So basically HPA can make a scaling decision based on custom or externally provided metrics, and works automatically after initial configuration. So here you need to define the min and max number of replicas. Like let me show you. So basically this is the command kubectl autoscale deployment. Okay, auto deployment. This is the, suppose you have your application name is PHP Apache. So GPU percentage is 50. So this you have set the threshold here, and min 1 and max 10. So in this way you have to define the what should be the minimum replicas and what should be the maximum replicas that need to be run. One and now, so basically when it is configured, so once you have configured the HPA, it take total charge of checking the metrics like CPU, and then scale up and down the replicas accordingly. And by default it checks the metrics every 15 seconds, which I had just explained in a few minutes back. Now, so basically now HPA depends on another Kubernetes resource known as metric server to check the metrics. So basically metric server provides the data like CPU, memory usage of the nodes and pods. On the basis of that data, a metric server basically HPA check the metric servers and take action accordingly. So now understand how it works. So basically HPA query for metrics to the metric server. First step is HPA queries for metrics to the metric servers. Now second, calculate the replicas. After that, checking the metrics, it check the replicas. How many replicas are there? Then third is update the replica count here. Suppose you have mentioned that maximum 5%. It depends on that. It updates the replica count. Then fourth is the scale the desired replicas. Suppose you want to scale is 5 to 10, from 5 to 10, then it will gradually increase from 5 to 6, 7, 8, 9, 10. So this whole action basically takes 4 steps. Let's understand here. So these are the 4 steps that are followed every time. Queries for metrics, calculate the replicas, update the replica count, and scale the desired replicas. In during the scaling down, it again follow the same step. Query the matrices, calculate the replicas, update the replica count from 10 to 5, what was the default set, and then scale down the desired replicas. But while implementing HPA, you have to make sure that you have efficiently set CPU and memory limits to the pods. Your pods may terminate frequently, or other end of the spectrum, you will waste your resources. And one more thing, if the cluster is out of capacity, HPA can't scale up until new nodes are added to the cluster. So these things you have to make, these are the prerequisites for implementing the HPA. You have to make sure that you have defined the CPU and memory limit to the pods at optimum level, and cluster should not be out of the capacity. There should be proper capacity to the cluster. What if you require 2 or 3 nodes, that should be assigned properly, otherwise HPA will not work. And for this you can implement cluster autoscaler. So basically there is one more thing. I explained vertical autoscaling, horizontal autoscaling. Then there is one more thing, that is cluster autoscaler. So cluster autoscaler automatically adds or removes nodes in a cluster based on resource request from the pods. Unlike HPA, which basically depends on the which works on the memory CPA or CPU, cluster autoscaler does not look memory or CPU. It just triggers the autoscaling depending on some events or some checks for any unscheduled pods every 10 seconds. So here I am showing you one example where you can check how it works. So for explaining this, I have created one YAML file, that is PHP YAML. So basically in this file I have just created one deployment, that is name is PHP Apache, and it's using the container name PHP Apache. It will I have defined the port 80. I have given the CPU 500 M and limits. I have set the limit and request is 200 M. You can change according to your requirement and your application. And here I have defined the service, PHP Apache, name of service, and port is 80. Now just let me create the deployment. So basically it is the same command, kubectl apply -m. So you have seen that you can see that the deployment and service both is created. Kubectl get pods. You can see that one pod is running, and you can see that one service is PHP Apache service is also running. Currently you can see that only one pod, so there is one in replica set. It is showing just one pod. Now I have defined that now we will create a horizontal pod autoscaler. So this command kubectl autoscale deployment. Which deployment you want to autoscale? Give the name of deployment, php-apache, then -f CPU % equal to 50, and min equal to 1, max equal to 10. Here you can define min and max value. So basically 50 is that it have to maintain average CPU utilization across all pods of 50%. So basically this will explain it will create the HPA, which HPA controller will increase or decrease the number of replicas depends on the average CPU utilization, and it have to maintain at 50%. So now it is showing that your deployment is auto scaled. You can check. So you can check that it has defined min pods, max pods, replicas, age 16 seconds. This is, you will get a similar output when you run this command. So you can see that the current CPU consumption is 0% as there is no client. It is showing currently unknown, but it will show you 0% or 1%, depends on your application. Now we will open a new terminal. So basically from new terminal we will generate the load on the pod. So for this I am giving the command, just copy it and paste it. Now you can see that another terminal. So basically in this way it is just creating the load on the pod. So let's see. So basically load is getting generated, but you can see that, but it will not showing here because we have not installed the metric server. So when you install the metric server, you can see that it will show the target here the current CPU utilization, 60%, 70%, 100%, 200%, and then you can see the number of replicas has increased from 1 to either 10, 7, 8. So for this you have to install the metric server. So for installing and configuring the metric servers, I will show you in another video how to do this. So for this video you can use this is the process where you can check your deployment and your setup of the HPA. So if you want to stop the load generation, you can just Control C here. Now that is the process is terminated, and then when you terminate it, you can see after a few minutes that it will back to normal state. But for this, metric server should be installed on your Kubernetes. So I will show you installation and configuration of the metric server in next video, and again in there I will show you how to generate the load. So that is enough for this video, and please subscribe my channel so that you always keep updated with the latest and upcoming videos. Thank you guys, and so basically this is the channel link. Please subscribe it and keep updated yourself for the latest and upcoming videos. Thank you guys.